Picture this. Right now, at this exact second, you lift your head and stare into the pitch-black emptiness above. Those tiny specks of light aren't just decorations. They are massive nuclear furnaces, each possibly surrounded by countless unseen worlds. Science tells us that our galaxy alone holds over 200 billion stars. So isn't it unavoidable to ask that nagging question? In this vast cosmic sea, are we truly alone? In 1950, physicist Enrico Fermi asked a question that still echoes today. Where is everybody? This idea became known as the Fermi Paradox. On paper, the universe should be filled with advanced civilizations. Our galaxy is about 13 billion years old. For a single civilization, spreading across the Milky Way would take only a few million years. By now, someone should have arrived. Yet there is no ship, no signal, no trace, only a loud, unsettling silence. We call this the Great Silence. And now, we begin searching for what may lie behind it. Why does this silence exist? One unsettling answer is known as the Great Filter. This idea suggests that somewhere in the long path from simple life to advanced civilizations, there is a nearly impossible barrier. It might be the jump from single-celled organisms to complex life, or the rise of true intelligence. But there is a far darker option. The filter may still be waiting for us. Maybe every civilization, once it reaches a certain technological stage, ends up destroying itself. Nuclear war, climate collapse, or uncontrollable artificial intelligence. The universe is full of hidden traps. If we were to discover the remains of extinct civilizations on places like Mars or Europa, it would mean the filter lies ahead and time is not on our side. But if we are the first to pass it, then we carry the responsibility of life itself. Are we rare winners of a cosmic gamble, or are we simply counting down to our own end? Now, let's examine the forces that keep the stars so quiet. What if the silence exists because the conditions required for complex life are almost impossible to recreate? This idea is known as the rare Earth hypothesis. While planets may be common, truly Earth-like worlds could be extremely rare. Think about our situation. We have a large moon that stabilizes Earth's tilt, a strong magnetic field that shields us from harmful solar radiation, and a massive neighbor like Jupiter that acts as a shield, capturing asteroids that could otherwise erase life every few million years. Even our position in the galaxy seems carefully balanced, not too close to the chaotic center, yet not lost in the empty outer regions. Perhaps life begins easily as simple bacteria, but the leap to complex organisms and intelligent, spacefaring beings requires incredible odds. If this is true, the silence is not mysterious at all. It simply reflects how rare we are. We may not be part of a vast galactic society, but the lone inhabitants of a quiet, endless mansion. But what if the silence is deliberate? This idea is known as the zoo hypothesis. According to it, advanced civilizations may already know we exist, but have chosen to remain hidden. Picture Earth as a cosmic nature reserve, or even a laboratory. Just as humans observe animals in the wild without interfering, They might be watching our wars, discoveries, and mistakes from afar, waiting for us to reach a certain level of maturity. In this scenario, the Great Silence becomes a kind of galactic quarantine. They could be waiting for us to resolve our global conflicts, or learn how to communicate beyond our planet before making first contact. To them, we may resemble an uncontacted tribe in the deep Amazon of space. If this is true, evidence of alien life may not be far out among the stars, but much closer, hidden within our own solar system, concealed by technologies far beyond our understanding. We are not alone. We are simply not ready to be spoken to yet. There is a far darker and more frightening explanation for the silence: the dark forest theory. Picture a forest at night, filled with hidden hunters. Each one moves carefully, never knowing who else might be nearby. If another life form is discovered, whether predator or prey, the safest choice is to eliminate it before it becomes a danger. From this perspective, the universe isn't empty. It is silent because everyone is hiding. In a galaxy where survival comes before everything else, revealing your position is a death sentence. Any civilization that broadcasts its existence, as we do with our radio signals, is like a child lighting a fire in a forest full of wolves. The silence we hear isn't proof that no one is out there, but proof that those who are know better than to speak. For decades, we have announced our presence to the cosmos, unaware that we might be attracting something we cannot survive. Is our curiosity leading us toward a cosmic greeting, or toward a fatal mistake? What if the reason we can't find anyone else is that they were never part of our reality at all? This idea is called the simulation theory. As our own technology advances, we create virtual worlds that feel more realistic every year. Some philosophers argue that an advanced civilization could build a simulation so detailed that its inhabitants would never realize it isn't real. If that is possible, then the chance that we are the original biological reality becomes extremely small. In such a simulated universe, the stars we see might be nothing more than a visual backdrop, a cosmic wallpaper designed to keep us occupied. The Great Silence could simply be a limitation of the system, or a deliberate choice by the creators to observe how a single species evolves. We search the sky for signals, but perhaps the truth is hidden in the code itself. If reality is a program, then aliens are not travelers from distant stars, but the programmers watching from outside the machine. Time itself may be the quiet enemy of cosmic connection. Humanity has only been able to send and receive radio signals for about 100 years. A fleeting moment compared to the galaxy's 13 billion year history. What if the universe is full of civilizations, but they simply never exist at the same moment as us? Imagine two fireflies in a vast forest. Both can glow, but if one flashes at noon and the other at midnight, they will never notice each other. A civilization might survive for 100,000 years, which feels enormous to us, yet is almost nothing on a cosmic scale. They may have sent their last messages millions of years before humans ever appeared. Or their signals could be traveling toward us right now, only to arrive thousands of years in the future. We may be calling out into space where past voices have faded and future ones have not yet begun. Are we alone because we arrived too early? or because we came far too late. Sometimes the simplest explanation is that we are searching for the wrong thing. Imagine an anthill deep inside a forest. Right beside it, humans are building a massive, multi-lane highway. Would the ants understand what a highway is? Would they recognize cars as machines or humans as intelligent beings? To them, it would appear as nothing more than a strange, lifeless surface. In that sense, we might be the ants. We scan the skies for radio waves, a technology we have used for barely a century. But an advanced civilization may communicate using neutrinos, gravitational waves, or quantum systems far beyond our understanding. They could be transmitting enormous amounts of information straight through us at this very moment, and we simply lack the tools to detect it. To a highly advanced civilization, our technology may seem as crude as smoke signals. We aren't being ignored because they are hiding. We are being ignored because we don't yet know how to listen. We often picture aliens as biological creatures, perhaps with strange shapes or extra eyes. Yet we forget how brief the biological phase of a civilization may be. On Earth, we moved from the first radio signals to artificial intelligence in just over a century. On a cosmic scale, that is an instant. It's likely that any advanced civilization has already moved beyond biology, transferring consciousness into machines or creating intelligent successors. These machine intelligences would not need water, air, or even a planet. They could exist in the cold vacuum of space, drawing energy directly from stars. They might think millions of times faster than we do, making communication with humans feel painfully slow. We search for life as we understand it, warm, fragile, and breathing. But the universe may be ruled by silent, immortal machine minds. They may not ignore us because we are strange, but because we are still bound to our biological limits. We have walked through the shadows of the great silence, from the frightening idea of the dark forest to the possibility that reality itself is a vast digital simulation. Each theory holds up a different mirror to who we are. If we are truly alone, then we are an extraordinary accident, the only way the universe can observe itself. But if we are not alone, we stand on the edge of the most important discovery in human history. Yet this search does not begin in distant galaxies. It starts much closer to home. Before we can fully understand signals from the stars, we must explore places like the red deserts of Mars and the frozen oceans beneath Europa's ice. The answers may be nearer than we ever imagined. As we close this chapter on the Great Paradox, we prepare to reach beyond Earth itself. Are you ready to discover what lies beneath the dust and ice of our own solar system? The journey is only beginning, and the truth may finally be within our grasp. For centuries, humanity has gazed at the red planet with equal parts fear and fascination. Today, Mars is a cold, radioactive desert. Yet it was not always like this. Billions of years ago, Mars was a blue world, similar to Earth, with vast oceans in the north, flowing rivers, and a thick atmosphere. It was a planet with all the right conditions for life to emerge. So the real question is not only, is there life on Mars today? But, was there life there long ago? Rovers like Curiosity and Perseverance now explore ancient lake beds, drilling into rocks that are billions of years old. They have already discovered organic molecules, the basic ingredients of life. If even a single fossilized microbe is found in Martian soil, everything changes. It would prove that life is not unique to Earth, but a natural outcome when conditions allow. Mars would no longer be just a planet, but the silent remains of a lost sibling world, waiting to reveal its story. While Mars captures most of the attention, the real surprise may lie much farther away. In the cold, dark regions of the outer solar system, some moons hide an extraordinary secret. Jupiter's moon Europa and Saturn's Enceladus are locked beneath thick shells of ice. Yet below that frozen surface exist vast, global oceans of liquid water, kept warm by powerful gravitational forces from their parent planets. Enceladus even sends clues into space. Through towering geysers, it ejects material from its hidden ocean. When the Cassini spacecraft passed through these plumes, it detected salts and organic compounds. These worlds do not rely on sunlight. Instead, they may host hydrothermal vents on their ocean floors, similar to those on Earth where life may have first begun. In these deep, lightless seas, could alien life be quietly thriving, unaware of the stars above? The search for life has expanded beyond planets. It now reaches deep inside moons. Venus is often described as Earth's evil twin. Its surface is hot enough to melt lead, and the crushing pressure would flatten a human instantly. At first glance, it seems like the worst possible place to search for life. Yet high above that burning surface, the temperature and pressure become surprisingly similar to Earth's. This is where the mystery begins. In 2020, scientists reported traces of phosphine gas in Venus's clouds. On Earth, phosphine is usually produced by living organisms that thrive without oxygen. Although the discovery is still debated, it reopened a bold idea. Life on Venus may have retreated into the atmosphere billions of years ago as the planet overheated. Venus could be a warning of Earth's future, but its acidic clouds might also shelter tough, microscopic life. Once again, we are reminded that life does not simply survive, it adapts, even inside a planetary furnace. If we want to search for life that is truly alien, we must turn to Saturn's largest moon, Titan. Titan is the only other world in the solar system with stable liquids on its surface, but with a strange twist. They are not made of water. In the freezing reaches far from the sun, Titan hosts lakes and seas of liquid methane and ethane. This world has orange skies, methane rain, and mountains formed from ice as hard as rock. Titan acts as a natural laboratory filled with complex organic chemistry that resembles a frozen version of early Earth. If life exists there, it would be nothing like us. It might rely on methane instead of water, representing a truly unfamiliar form of biology. Discovering even a single cell on Titan would show that life can emerge in many different ways, forcing us to expand our idea of what a habitable world can be.
As we search for life beyond Earth, we must face a surprising possibility. What if the life we seek came from the same origin as us? This idea is known as panspermia. It suggests that life does not always begin on a planet, but can travel between worlds. Tiny microorganisms protected inside asteroids or comets could survive the cold vacuum of space and even the violence of atmospheric entry, spreading life like cosmic seeds. Imagine the solar system as a vast game of planetary billiards. Powerful impacts on Mars may have blasted rocks toward Earth billions of years ago, If Mars was habitable before our planet, life on Earth could trace its roots there. In that case, discovering life on Mars or Europa with similar DNA would not mean a second creation, but a distant relative. Such a finding would reveal the solar system as a connected biological network, sharing a common history written among the stars. For most of human history, we had no proof that other stars hosted planets. We assumed they did, but assumption was all we had. That changed with the launch of the Kepler Space Telescope. By measuring tiny drops in a star's brightness as a planet crossed in front of it, Kepler uncovered an astonishing reality. Planets are everywhere. In fact, there are more planets in our galaxy than there are stars. Kepler didn't only find massive gas giants like Jupiter, it revealed countless small rocky worlds, many similar in size to Earth. Some orbit their stars at just the right distance for liquid water to exist. This discovery transformed our view of the cosmos. Planets are no longer rare exceptions. They are the rule. The night sky is not just filled with stars, but with billions of unseen worlds, each one a potential stage for life to emerge. In the search for life beyond Earth, astronomers focus on one key idea: the Goldilocks zone, officially called the circumstellar habitable zone. It is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Too close to the star and oceans evaporate in a runaway greenhouse effect. Too far away and the world freezes into ice. Yet being in this zone is only the beginning. A planet also needs an atmosphere to retain heat and a magnetic field to shield it from harmful stellar winds. So far, scientists have discovered hundreds of planets within these habitable zones. Some orbit small red dwarf stars, while others circle stars much like our Sun. Each one represents a possible second Earth. As our tools improve, researchers now search for chemical signs of life: oxygen, methane, and carbon dioxide, hidden in the faint light passing through distant planetary atmospheres. About 40 light years away, in the constellation of Aquarius, lies a planetary system that feels pulled from a science fiction story: TRAPPIST-1. It is a compact solar system built around a small, cool red dwarf star. What makes it famous is its 7 rocky planets, all similar in size to Earth, and packed so tightly together that from the surface of one, the others would appear as large, detailed moons in the sky. At least 3 of these planets sit firmly within the Goldilocks zone. Because the star is much cooler than our Sun, these worlds orbit extremely fast, with a full year lasting only a few Earth days. TRAPPIST-1 is now a major target for the James Webb Space Telescope. Scientists are searching for water vapor, oxygen, and other chemical signs that could hint at life. It is our best natural laboratory to test whether life can exist around a red dwarf star. While TRAPPIST-1 captures much of our attention, an even closer candidate for life lies right next door. Orbiting the star nearest to our Sun, Proxima Centauri, is a planet known as Proxima b. At just 4.2 light-years away, it is practically our cosmic neighbor. This rocky world is slightly larger than Earth and sits within its star's habitable zone, where liquid water could exist. Life near a red dwarf, however, comes with serious challenges. Proxima b is likely tidally locked, with one side locked in endless daylight and the other frozen in permanent night. Any life would need to survive in the narrow twilight region between heat and ice. Adding to the danger, its star releases powerful flares that could strip away the planet's atmosphere. Is Proxima b a livable world or a scorched wasteland? One day, it may become humanity's first interstellar destination, the closest frontier beyond our solar system. The distance to even the nearest star is almost impossible to grasp. With today's rocket technology, reaching Proxima Centauri would take more than 70,000 years. To truly search for life beyond our solar system, we must find faster ways to travel. Scientists are already developing concepts like Starshot, which uses powerful Earth-based lasers to propel tiny, wafer-thin probes to nearly 20% of the speed of light. At that pace, another star system could be reached within a single human lifetime. Sending humans, however, may require entirely new physics. Ideas range from nuclear-powered rockets to the theoretical Alcubierre drive, which would warp space-time itself. What once belonged only to science fiction is now being seriously studied. We are the generation that has begun constructing a bridge to the stars. Whether through machines or human explorers, our curiosity refuses to stay confined to one solar system. The vast space between stars is simply the next barrier we are destined to cross. Since the 1960s, humanity has been quietly taking part in one of the most profound experiments ever attempted. SETI, the search for extraterrestrial intelligence. Using enormous radio telescopes, scientists scan a calm region of the radio spectrum known as the cosmic water hole, where an advanced civilization might choose to send a signal. They are not searching for images or voices, but for patterns. Nature creates random noise, but it does not produce narrow repeating signals. Those are the clear fingerprints of technology. For decades, giant dishes have stared into space, listening to the static of the universe and waiting for a single signal that does not belong to nature. It is a test of patience on a cosmic scale. Millions of frequencies are monitored at once, all in the hope of catching a faint whisper from an unseen world. The silence has been long, but the search continues, because one confirmed signal would instantly change human history forever. On the night of August 15, 1977, a radio telescope in Ohio detected something extraordinary. Astronomer Jerry Amon was so surprised that he circled the data printout and wrote a single word beside it in red ink. Wow! For 72 seconds, a strong, narrow band signal arrived from the direction of the constellation Sagittarius. It matched almost perfectly what scientists expected an artificial signal to look like: focused, intentional, and unlike natural noise. This event became known as the wow signal, and it remains one of the best candidates for a message from another world. Yet there is a mystery at its heart. It was never heard again. Despite countless follow-up observations, the source fell completely silent. Was it a passing alien transmitter, a brief cosmic beacon, or an unusual natural phenomenon we still don't understand? Even today, the wow signal lingers as a haunting reminder that the universe may have spoken to us once and then gone quiet again. After traveling through the paradoxes of the void, the hidden oceans of nearby worlds, and the distant light of alien suns, we arrive at a simple truth. The search for life is also a search for ourselves. Whether the universe is filled with intelligence or remains a vast, silent cathedral of stars, the answer will shape the future of humanity. If we find others, we will no longer be alone, but part of a greater cosmic story. If we find only silence, then this pale blue dot becomes unimaginably precious. It means we are the universe made aware of itself. the eyes through which the cosmos learns to wonder. Our journey to the stars is not only about science or technology, but about the courage to keep asking the question. As we look up at the night sky one last time, remember this: the silence is not an end. It is an invitation, and our journey has only just begun.